So this is the electron cloud section of the test. First question, what's the correct sequence in which the following sublevels will fill? I'm going to turn on my pencil here. There it is. So what we do is we look at the sequence, 1s, 2s, 2p should be next, so that one, we know that one's out. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, that looks pretty good. The way you know for sure is to check your periodic table. So here's a periodic table, 1s is first, then 2s, then 2p. We're just going in order of increasing atomic number. Then 3s, then 3p, then 4s, 3d, then 4p, then we come to 5s, see right there it says 5s, then 4d, then 5p, we're now over here, 5p, then 6s. Notice this little symbol right here says to go down to the bottom, so it's tied in right there. So 6s, then 4f, then come back after you've gone through YB, come up to LU, which is in part of the 5D. So 5D starts there, and then you go straight through to 6P. And whoops, don't want to do that. Then 6P. After 6P is 7S, then 5F, then 6D. So that's the filling sequence. So if we go back to the test, we can see the correct answer on number 1 should have been C. Okay, number 2, the correct sequence, a little more complicated, yet they all start with 4P or 5S, but I think this may be it. Let's see. No, that's wrong. That's because if you have 5S, 6S, that doesn't make any sense. That's wrong. 4P, 5S, 4D, 5P, 6S. 4F was after that, so I'm going back up here. 4P, 5S, 4D, 5P, 6S, 4F, that sounds good. 5D, 6P, 7S. That's the one that matches the periodic table. Number 3, you're looking for an invalid sublevel designation. Well, invalid means it doesn't exist. So in the first energy level, we have an S. In the second energy level, there was an S and a P. In the third energy level, there was an S, S, a P, and a D. In the fourth, there was an S, a P, a D, and an F. So you don't see an F until the fourth energy level. That was the third energy level, that's the second, this is the first. So there is no 3F. 3F doesn't exist, so that's your correct answer, that's invalid. Now orbitals, when we talk about orbitals, we remember this was a p orbital. Not a very good artist in general, especially not on this tablet. But there we go, there's a sort of a p sublevel that looks like what we have on the ceiling in the classroom. The S sublevel looks like a model of that, or it looks like a circle here. It's confusing my computer. So that's kind of what the atom would look like, and although I didn't intend to, I created this fuzziness around here, which is kind of what it looks like. The orbitals are regions in space where they go around the nucleus. The nucleus, of course, would be a little pinpoint right here in the center. And the electrons move around that nucleus, but they don't move in a specific direction. They're just somewhere out there, and we never really quite know where they are. So we would say that the orbitals are regions in space where an electron is likely to be located. They're not a specific path, they're a region. All right, in the P sublevel, if you remember, we went back to number 5. So there's our S sublevel, 1S, 2S, 2P. I'm not going to go bigger than that because of space. Okay, so how many electrons can be in this P sublevel right there? Well, you could have an up arrow and a down arrow and an up arrow and a down arrow and an up arrow and a down arrow. So that would be 6. If it was a D sublevel we're talking about, like in number 6, you'd be looking at 5 boxes. So how many electrons could be in the 5 boxes? Each one can hold 2. 5 times 2, 10. And if they are in the same box, did you notice that I put arrows that are going both up and down in both boxes? The reason that they go up and down is to try and show that they have an opposite spin from each other. So the correct answer would be B. And then if we drew the arrows in for nitrogen, if you look at the periodic table, on the table it says nitrogen is 7 and its mass is 14. That means it has 7 protons and the mass is 14, so it'll be 7 neutrons also because 7 and 7. and the electrons would also be 7. So 1, 2, 3, 4, 5. Now remember Hund's rule, the electrons go in one at a time. 5, 6, 7, like that. So our number of unpaired electrons would be 3. 1, 2, 3. That's first page. Now sublevels in the third energy level. Now I kind of drew that out for you earlier, so look back up here, right here, oh not there, right here, S, P, and D in the third energy level. So that's 3, S, P, and D, so the answer to that one would be C. And orbitals in any p sublevel I drew out for you right here. So how many orbitals? 1, 2, 3. So the answer would be 3. Okay, and we talked about if electrons are pairing up in orbitals, will they go in one at a time or will they go in until all are occupied? They fill all orbitals with one electron before pairing. That's what I'm doing when I do this. And I had those 3 p orbitals a minute ago. 1, 2, 3. They don't pair until there's 1 in each box. Okay. Now the valence or outer shell of oxygen. Here's oxygen. Look at the periodic table. It's 8 and 16. Just in case you don't believe me. Here's oxygen, 8 and 16. So the 8 right there, and its mass is 16. So, let me get back into my other document here. There we go. So 8 electrons. If we write the electron configuration for oxygen, it's 1s2, 2s2, 2p, 4. So I don't have enough electrons to put all 8 electrons in oxygen. Excuse me, all 6. I don't have enough electrons to put all 6 electrons that could go into the p orbital. If I drew the electron orbital notation like this, I would have 1, 2, 3, 4, 5, 6, 7, then 8. All right. Now the outer shell includes only the highest energy level. So that would be, if you look up here, on the highest energy levels right here with 2 and right here with 2. So correct answer would be the 2 that are here this is an interesting thing I'm learning about as we're doing this. So there'll be 2 there, be 2 there. So I've got, in the outer shell, looks like 2 plus 4 is 6. So 2s and a 2s. And 4 2p electrons. Make 6 in the outer shell. So my correct answer here for the number of electrons in the outer shell of oxygen, 6. The highest coefficient, the coefficient of the highest energy level in arsenic. So to do that, we're going to flip back over to the periodic table. We're going to find arsenic. It's right here, As. This is the first energy level. There is no P sublevel in the first energy level. You notice we're all in this is the P block over on this side. So there is no 1p, but there is a 2p, and there's a 3p, and there's a 4p, and a 5p, and so on. Arsenic is in the 4p row. See it right here? Right there, arsenic in the 4p row. So since it's in the 4p row, we know that the coefficient on it in its outer shell is 4. Right there. Right? So the answer to that question was 4. So number 13, 4. All right, which subatomic particles are transferred to each other during a reaction with some other compound? Well, the electrons that interact are on the outside. The part of the atom that interacts with other atoms will be the outside, and electrons are on the outside. So the answer to that one should be electrons. All right, now the matching. The easiest to do this maybe if I brought this will take me just a second. Oops, I'm going to shrink this up a little bit. Like that. Okay, come back down. I'm going to make this a little smaller. All right, so in the D block, there's vanadium. So it's right here. See, it's in a D block, 3D. So the answer to number 1 there would be A. The F block contains which one of these? Well, uranium, if you look right, is right down here. So uranium. So the F block contains uranium. That's D. The S block has magnesium in it. Magnesium's right here, see? That's in the S block, so that's C. And then uranium, that leaves for the F block. Or the P, no, I skipped that. The P block, that's what I meant to say, contains lead. Lead's the only one left, so that's B. And if you look over here, here's lead in the P block. Right there, and see that's 6P. Okay, now the last thing, this sequencing, is how, the way I would do that, I would look at the sequence on the periodic table. Remember, it goes 1s and 2s, then 2p's over here. Well, 2s was right here, underneath there, hiding underneath that other document. So we'd put a 1 in front of the 2s. Then we'd come across 2p we don't know about. It's not listed. 3s is not listed. 3p is not listed. 4s, not listed. 3d is listed. See, it's down here. Ah, shoot. So 3d is right here. So we'd put a 2 in front of 3d. Then after 3d is 4p, and 4p is not listed. Then it's 5s. 5s is listed, so that'd be number 3. Then after 5s is 4d. So write 4d. Don't see any 4d. And then there's a 5p. I do see a 5p. So 5p is the fourth one. Then after 5p comes 6s. There is no 6s listed there, but here it is down here. And after 6s comes 4f, and 4f is listed. So that'd be a 5 up here. After 4f, what did I say? It comes back up to 5d. No, 5d is not listed. After 5d is 6p. 6p is listed. So that gives us that's our 6th. Okay, after 6p comes 7s. Right there. 7s is not listed, but 5f is. So there's 7s, and you come down to 5f down here. So 5f is 7. Then after 5f is 6d. That's the next thing. All right, I'm going to stop the recording at this point and post this one because it's getting kind of long, and then I'll make a separate one for the last page of this section.